Alright, so we talked about how to test solutions of a linear inequality, and we talked about how graphing that linear inequality would graph all the solutions. Remember, we talked about how you graph it basically just like a line by solving for y. Then your points are going to be on the line if it has an equal to sign, and shaded on the side of where the inequality tells you to shade. Less than or equal to means on the line or below. Greater than or equal to would be greater than or equal to. Less than would have a dotted line shaded only below. Greater than would have a dotted line shaded only above. So the solid line tells me the solutions on the line work. The dotted line tells me that the solutions on the line don't work. So here I have basically the steps that I use when I'm graphing one of these inequalities. You can pause the video and write these down, or you can just refer back to the video whenever you want. Basically, you graph the boundary line just like an equation. If it's a less than or greater than, you do a dashed line. If it's less than or equal to, greater than or equal to, you do a solid line. Then you shade below or above. If it's less than, you shade below. Above, you shade greater than. You can also have some test points if you wanted to, like we did here. We knew which points were solutions. But using kind of the finger on the line trick and shade below or above usually works out pretty good. So now what I'm going to do is I'm going to go through these 5 problems at the bottom of the page here. You can pause the video here and you can see the examples and you can try them before I go through them, because I'm going to go through them very quickly on this video. So again, you can try them if you pause the video here, then you can unpause to see the solutions. So on the first one, y is less than 2x plus 3. I'm going to begin at 3. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1. Notice it is a less than sign, so that tells me I'm going to have a dotted or a dashed line across my paper, because equal to means solid line, because the points on this line will not work. Then I shade less than. If you put your pen or your pencil on the line, or you put your finger on the line, go to the points that are lower. Don't think left and right. Think points that are less than the line. Excuse me. On this one, you're going to have to solve it first. So the first thing you're going to have to do is you're going to have to subtract the 6x over to the other side to end up with negative 4 minus 6x. Then you're going to divide by 2. Once you divide by 2, that will give you y is greater than or equal to negative 2 minus 3x. So if you begin at negative 2, and then you go down 3 over 1, down 3 over 1, you can connect your dots with a solid line, because the equal to symbol tells me that every point on this line is a solution. But you also have the shading. Greater than tells me to shade above the line. So if I put my finger or my pencil on the line, I will shade above the line this way. Begin at 2 on this one. My slope is negative 1 over 2. Negative 1 over 2. It is going to be a dashed or dotted line, if you will, because it does not have an equal to sign, and it is only greater than, so I shade everywhere above the line. Again, using your finger on the line and going to the points that are greater, going to the points that are greater, going to the points that are less than. That is how you decide where to graph. You can also pick points and test, like we did up here with these test points. The last two, really quickly, are horizontal and vertical, because this one is only y, this one is only x. So on the horizontal and vertical, you would have